Although they are never in the forefront of our perception, one doesn't have to walk far or look hard to see the vast number of storm drains that empty directly into the Mississippi River. All of these shots that you see were taken only on a 300-foot stretch of the river. Most of the entrances of these pipes come directly from these familiar-looking slots located conveniently uphill and all around campus. Some are even marked to say that they flow directly into the river with no treatment whatsoever. On the hill behind Kaufman Union, these pipes are exposed once about every 100 feet. That should really put it in perspective how much water is draining directly from the streets to the river. According to the Minnesota Stormwater Steering Committee, when roads and buildings are being constructed, sediment is transported into the streams at rates of 5 to 500 times those of undeveloped areas. Also, according to the MPCA in 2008, sediment has been labeled the most important pollutant in U.S. rivers and streams and is the primary impairment of 60% of impaired rivers nationwide. However, in construction situations that take place in the metro area, heavy inspection and specific permits must be obtained before any work can be done. Van An Tai, a member of the university-wide Environmental Health and Safety Board, explains.
They, as part of a project, since anytime that they get to our land, the university property, that we require them to do treatment too. And actually, they did install along Beacon, between Harvard and Beacon Street. They did install last year an underground treatment because we require them to treat. So underground piping system that can take all the runoff from that Beacon Street.
At another construction site further up the street, sediment runoff doesn't seem to be the main problem, but simply water wastefulness. This pipe has been draining continually since before the academic year even started. Now, from what you've heard so far, you may think the outlook on the Minneapolis campus is pretty bleak. But as it turns out, newer buildings such as the TCF Stadium are implementing a wide variety of new infrastructure to combat destructive urban runoff.
We do have, in the front gate of the stadium, if you look closely, there are patches of pervious pavers, and they would use it to treat. So instead of regular concrete sidewalk, like normal sidewalk, is impervious. The water doesn't go through the pavement. So when the water hit the sidewalk, it just run sheet flow to the next storm basin. So the new thing about treating is this, they call pervious pavers.
Not only are pervious pavers used to enable infiltration, but the stadium is also surrounded by rain gardens of all shapes and sizes. The excess drainage from these rain gardens accumulate in a dry pond, seen here, which slows the pace of travel of the water and allows for more planted vegetation. Now, rain gardens and pervious pavers are excellent at reducing the flow of excess urban water. But what about garbage and solid waste that is carried along by that water?
And as far as construction site, you notice going around, they all have silk fence around it. Or in the storm drain on the street, they put a bag underneath. That's we require, the state requirement to catch solids.
But what about normal city circumstances? The St. Anthony Falls Laboratory near campus asked the question, can a standard manhole operate as a pollution reduction device? Manholes can retain a surprising amount of suspended solids. Unfortunately, these retained solids wash out at high flow rates and continue through the storm sewer system. November 2009 updates reported on research that documented a standard manhole retrofitted with a SAFO baffle. The graded metal seen here will capture solid materials as the storm sewer flow passes through the manhole area. Implementing concepts like the SAFO baffle, as well as retrofitting and replacing our storm sewer systems, is a major key in helping clean up our rivers and water supplies. Sometimes, the smallest of efforts in changing our habits can have the most profound and positive effects.